Hi, this video is about what you want to know about the game In Between, a game played using a normal deck of 52 playing cards. It covers how the game is played and comes with the objective to help you understand your odds for the various situations during gameplay. As what had been said, In Between is a game played using a normal deck of 52 playing cards. Only the numbers on the cards are considered for this game, and the ace card is treated as 1, jack as 11, queen as 12, and king as 13. These numbers represent the numeric order for the game. The game starts with the issuance of 2 playing cards to each player. Upon visualizing the 2 cards received, a player will make a call if the third card to be presented would be a number that is in between the 2 cards already being held. So when do you win? When the third card is a number in between the 2 cards you hold, you win. And when do you lose? When the third card is a number outside the boundaries of the 2 cards you hold, you lose. There's more. When do you get into a forfeit? When the third card is a number that is identical to any of the 2 cards you hold, you get into a forfeit. With the simple rules being laid out to you, all you now need to do is to decide the reward for each win, the punishment for losing, and the larger form of punishment in the case of a forfeit. Enjoy! And if you still think it's too much to remember, here are all the rules in one page. I've started by saying that it will help you understand your odds for the various situations during gameplay. In maths, this equates to the subject on probability. Now, there are 52 cards to the deck. After the first 2 cards are issued to the player, there is a 1 in 50 chance for each of the remaining cards being the third card. What does it mean? If the player has the cards 7 and 9, only the 8 cards will create a win. In such a situation, there would be 4 such cards remaining in the deck. Therefore, your chance of winning is 4 in 50. This equates to an 8% chance in your favor. In a separate situation, when the player has the cards ace and 10, the 2 until 9 cards will create a win. There would be 8 times 4 such cards remaining in the deck. Therefore, your chance of winning is 32 in 50. This equates to a 64% chance in your favor. In other situations, when the player has the cards ace and king, the 2 until Q cards will create a win. And this is your best odds for the game. There would be 11 times 4 such cards remaining in the deck. Therefore, your chance of winning is 44 in 50. This equates to an 88% chance in your favor. On the flip side, if the player has the cards 3 and 4, there will be no cards that will create a win. Therefore, your chance of winning is 0 in 50 or 0% chance in your favor. Such pairing, and when both cards are the same, would be your worst case. In summary, here is a table that indicates your chance of winning against the various situations that can occur for the difference between the larger and smaller card you hold. I must state that this is especially true only when the deck is reshuffled for each player. In other instances, it will only serve as a guidance. If you're one of those that like to think of it as a formula, your chance is equal to deducting the difference between the larger and smaller card by 1, then multiply it by 8%. Having understood this in probability form, there is no doubt that when a player has the cards ace and king, it is your best odds for winning the game. However, you still do have a 12% chance of getting into a forfeit. The calculation of probability can get more complex depending on how you play the game. In the instance when the game is played by 5 people and each is issued 2 cards up front, the remaining cards will no longer be 50 but 42. In this example, the first player's chance of winning now becomes 36 out of 42, which equates to a lower 85.7%, and the risk of being forfeited is a raised 14.3%. And complexity can work to your favor if you choose to also pay attention to other visible cards on the table. In this second example, the first player's chance of winning is 100%, as all the remaining aces and kings are already on the table. There is no risk of being forfeited in this situation. Having said everything that has been said, when luck is on your side, the word probability, chance, odds, and others of the same kind do not apply. This video is merely associating the subject of math to the game of in between. Bye bye for now, and from here you should be more equipped to use what you know about probability to up your game in between.